Good morning, everyone. Thank you for joining our webinar this morning about the topic of what is the true cost of manual monitoring. My name is Chris Ranvier. I am a pre-sales engineer for Redgate Software. My contact information is below, and I'm joined this morning by Jim Murphy, who is the CEO of SQL Watchman. Jim, do you want to tell everybody a little bit about what SQL Watchman can do?
Yeah, sure. Thanks, Chris. SQL Watchman. SQL Monitor is a tool that will help you find your problems in your SQL Server. And SQL Watchman, we perform services in order to help you try to resolve those issues. For example, who gets those alerts? Who watches the SQL Monitor to prioritize the issues that are found, schedule those issues for being resolved, and to actually fix those? If only there is a right-click fix issue kind of button, that would be great. We do ongoing maintenance, performance tuning, execution plans. We really act as your part-time remote DBAs to always be on duty for you.
All right. So this morning we're going to discuss a couple of different bullet points, and we'll see these being shown right now. So we'll go over the 5 biggest drawbacks of manual monitoring as we see in the real world. Also, what is the impact of that manual monitoring? And then how can you overcome all of those objectives with the use of a tool like SQL Monitor?
Okay, cool. Also, there's going to be time for question and answers at the end, so that feel free to put all your questions in the question answer box, and we will dig through those at the end. All right, excellent. Okay, so today we're going to talk about the 5 drawbacks of manual monitoring. With any monitoring solution, we're always trying to figure out, how is our SQL Server performing? How is it doing? How healthy is it? And we can either choose to not monitor the SQL Server. Pro tip, that's not a really good pathway to go. Or to find some kind of a way to figure out, how healthy is SQL Server? I can't tell you how many people come to us saying, gee, our SQL Server is not working very well. We found out because our customers are complaining that things are slow, and our IT folks or our developers, I don't know, they don't know. They can look at the CPU on the system or what have you, but it's really difficult to figure out exactly what is the problem. So really what we need to do is monitor much more in detail the SQL Server to learn what SQL is doing inside. And Microsoft doesn't provide these tools out of the box for you. It's really, you can either choose to hodgepodge together a whole bunch of various technologies and band-aid them together in order to make that sort of work, take some labor, or have some kind of a tool that will monitor for you and get all of the necessary information, but not the unnecessary information, so we can really understand. So we definitely want to make sure we monitor our servers. Failure to monitor our servers can lead to weak performance, unplanned outages, and also poor auditing. Some companies do adopt a manual approach to monitoring, but high-performing organizations generally are using tools to proactively monitor the SQL servers. This saves time, reduces errors, and really allows the DBAs to focus more on value-added work rather than just trying to keep up with, is the SQL Server performing well? We can actually start making improvements on the system with our time. So in this webinar, we're going to talk about the true cost of manual monitoring and how SQL Monitor can really help and ensure you don't miss critical and costly performance issues. Okay, so the first one. Manual monitoring is time consuming. That's because we normally start our day off as DBAs with a manual checklist, some kind of a, I don't know, 25-point or 30-point checklist, making sure last night's backups worked, make sure the T-log backups have worked all day long yesterday or today or what have you. Failed jobs, which jobs did fail, which jobs fail normally or have auto-correcting errors that you don't really have to worry about, and which failed jobs are really a problem. Then you got to extract those errors and get that off to the developers or debug them yourself in order to resolve the problem. We also have error logging, error log checking, looking for like severity 19, 20, 21, and so forth. Those sorts of errors. If replication breaks, somebody should probably know about that. Out of the box, SQL Server will happily, if replication breaks, for example, it'll happily throw an entry into the error log, but it requires somebody to go look at that error log in order to figure out something happened. SQL's not going to email you or notify you or wake you up at night or escalate it to another team member It doesn't do any of that out of the box. So, and it also doesn't look for things like 823, 824, 825, 605, I/O related errors. Those need to be configured. So that's more manual work to configure all that. Did CheckDB succeed? Is it successful? Do we have corruption? Did the reindex work okay? What about getting into things that's not just did the normal jobs run? What about memory and cache metrics? Which portions of which indexes are properly cached and which ones should be cached? What about perfmon counters or performance monitor, CPU, I/O latency, batch requests per second? And then even figuring out, what if batch requests per second is, I don't know, let's say 800. I don't know, is that good? Is that bad? Is that high? Is that low? Which brings us to our next point. The second piece to our monitoring is to baseline this. So if we start with a manual checklist, we just get a point in time. First thing in the morning, we do our check. I guess we're hoping to look at what happened yesterday, but nothing's going to tell us that unless we booby trap the system so that it's actually logging and capturing this all day long. So that's point number one. Point number two is, how do we figure out what is normal, what is abnormal, what is too high, what is too low? We need to compare all these metrics to a known baseline so that we know how our SQL Server is performing. Just trying to compare it to industry standards isn't going to work because everyone's server is sized differently. Everyone's workload is different. So even if you're getting batch requests per second of 100, that might be completely normal and not a cause for customer complaints. Or it may mean that essentially production is down. So it's very important for us to know how our system behaves in all these various metrics that we collect. Another example might be I/O latency of 15 milliseconds. I don't know, is that slow? Is that fast? Or how is that for our server? So we're going to kind of talk about that metric over and over again throughout this webinar. Also, when we look at what is normal for our server, that's not just what is generally normal for our server. Maybe we have an extra heavy workload in the mornings, or maybe we have month-end processing. So we really need to compare the metrics right now, not against a general baseline, but a baseline for how our server is performing this time of day, this day of week, or this time in the month, or year-end processing, or what have you, so that we can really know what is happening on our server. So we need to know a baseline. Doing a baseline manually is very difficult. There's lots of combination of technologies in order to try to record all the various bits and pieces so that and then we have to analyze it to really be familiar with what the issues are. Another thing we really should be aware of and know about is blocking. Again, so blocking is sort of a normal way SQL Server deals with things, right? One person gets a lock on some rows, and another person has to wait for that lock to be released so it can have a turn. That's called blocking. And blocking, when it's at the sub-second level, is normal. That's how SQL Server works. It's not a problem. But when it starts taking too long, and what does too long mean? Well, your customers can tell you. But it would be better if we were able to see blocking and set our thresholds and figure out, gee, if we have Sally in payroll and she's been waiting for longer than 2 or 3 seconds or 8 or 10 seconds or something like that, well, gee, there's a lot going on our server that's preventing her from doing her work. And in that case, we would really want to know about that so that we can start tuning the system. So how do we detect blocking? SQL doesn't do that out of the box, so we would need something. A lot of people might use SP Who Is Active. It's a favorite, a community favorite from Adam Mechanic. It's a great script. However, if you run that, here and there, then you're only going to get little snapshots. So really, what you want to do is have that running all the time, every 5 minutes or something like that. But what's more, you want to save that to a table. So you can configure that to save it to a table, and then you have to start purging that table. So there's a few options. So all I'm saying is it's not super simple and trivial, and it's another script to use in order to figure out blocking and set up the thresholds. You can also use PowerShell or some other technology like that. So the key point, the key takeaway from all this is without a tool, it'll be a whole bunch of scripts that we have to run and all these checks that we have to do every day throughout the day. And that can easily take us, what, 30 minutes, maybe an hour per server to run these checks, maybe. And even if we don't have to deal with any problems, it's still going to take some time. And if we do have to deal with problems, well, then it starts chewing into our day. And on top of all that is going to be a single check, and for example, the morning, so that we can see how things were, hopefully yesterday, I guess, which means we're going to be blind to all kinds of problems that happen throughout the day unless our customers complain at us. So even in all that, what we talked about, putting some of these things together, our monitoring is not really super effective when we do it the manual way. So with that, let's take a look at another option that we can do.
All right. So as Jim is saying, I mean, there's a huge number of things that you can and should check for. I mean, to do a good job as a DBA, knowing a server is up just isn't enough anymore. You need to ensure, for example, as Jim said, have any jobs failed? Have any backups failed? Will disk space run out soon? These are just a few off the top of my head, but checking all of this manually, as you guys know, can take hours. But you can see all of this information at a single glance using the global dashboard in SQL Monitor. This lets you know instantly where there are any problems without having to check a bunch of things out server by server. Here you can see this view. Obviously, I'm showing a couple of different estates here. I'm monitoring SimpleTalk and SQL Server Central, a couple of backend websites that Redgate sponsors. If I have a very large estate, I can collapse that view down here so I can really have an instant view holistically, depending on how robust that estate is. Over on the right-hand side, an alert history, right? This alert history is fantastic. It gives me as the DBA an idea of the type of alerts that are coming into my estate, which instances might be more susceptible to getting those alerts and so on. So this gives me a good idea in terms of doing maybe some initial triage or an investigation to maybe looking at some performance tuning aspects. If I drill into one of these instances, and I just want to kind of show you all, the baselining feature that, again, very important in terms of just understanding the behaviors of an estate and the amount of work that it goes into doing data collection to get that kind of baseline. When you deal with SQL Monitor, as you can see, I could just go ahead and select baseline, and this will give me a very decent graphical representation of what is normal, okay? I can see that, based on all of those metrics that we are collecting, CPU, memory, disk I/O, as well as weights, a fantastic attribute to a tool that takes so much of the work out of your daily, aspects of life. And just having this information, I think, is just a godsend in terms of doing monitoring.
Man, that is really cool. Do you have any idea how much time that saves compared to the manual? It's not fair, Chris. Okay, excellent. Well, thanks for the demo. That does solve a whole lot of those initial problems. Okay, let's go on to the next issue. The next issue is when we do things the manual way, we tend to increase our risk of failures. Well, what kind of failures? Well, let's start off with human errors. Now, if you have a daily checklist of 25, 30, 40 different points to check, and that's for each server, man, it might be exciting for a DBA to begin doing the first week or the first day, but man, shortly after that, it starts getting boring. So it's going to be real hard to keep junior DBAs engaged. Forget about mid-level, especially senior DBAs. They are not going to want to sit there doing the normal daily checklist stuff all day long. They'd quit. So of course they would turn to some way of automating and things like that, which is essentially building a whole lot of monitoring things, which takes a tremendous amount of time and a tremendous amount of labor and effort. And of course, if we don't have those things in place, well, then we're spending all of our time manually monitoring, manually checking, and manually reacting to all that stuff, rather than doing real DBA work, more like value-added DBA work, performance tuning and planning, HA, high availability related solutions, things like that. Another aspect to besides human errors is going to be that it starts adding technical debt. So when we start combining more and more various technologies together, it makes the monitoring environment more fragile. If we have, in some cases, jobs running all kinds of various SQL scripts, taking snapshots, throwing those into tables, now we need a separate database, which is cool. We start jamming in all kinds of data into those tables. Now we need other jobs to start purging that data away so that the database doesn't get too big. For example, if we have our blocking history, if we have perfmon, I mean, performance monitor is huge. I mean, when you look at how many metrics there are to record, there's everything that relates to SQL Server, but there's also things that relate to not just SQL Server. Maybe it relates to .NET. So, I mean, man, I don't think we need to monitor all kinds of .NET triggers. So there's this ocean of, I don't even know how many thousands. Is it near 10,000? I don't even know how many thousands of perfmon counters there are in all these various categories. And there's a ton of them just for SQL Server itself. So we don't just want to start perfmon and somehow click some record button so that it starts recording everything that's happening. It's too much of a load on the system, and it gets so much data that we can't kind of dig through it. So how do we dig through all of the performance monitor, CPU, I/O, SQL-related memory stats and cache and things like that? How do we extract those bits out so that when a problem happens or when we see an issue starting to happen, we're able to respond to that and proactively correct that, but not capture everything so that now we're drowning in data and dealing with that. So we have a combination of technologies. We have jobs running things, blocking histories, perfmon histories. We have maybe a little bit of PowerShell or maybe a lot of bit of PowerShell. PowerShell is pretty cool, by the way. Yet it's another install, another kind of framework piece. It works with the framework in order to deal with WMI calls, in order to get server metrics and whatnot. So we end up with all these PowerShell scripts and all these different folders based on what the scripts do. We have perfmon. We'll have to set up some kind of perfmon run. And by default, perfmon saves all of its results either to the screen, which that's useless in our case. So we can save it all to a file. That's pretty easy, but then we end up with all these different files all over the place. So there's a way we can configure perfmon to save all of its data to a SQL Server table, but kind of A, good luck getting that to work, and B, that's going to have to go through ODBC or SlowDBC. So that's yet another technology that needs to be set up and DSN's configured and all this kind of stuff. So we're starting to really paint a picture of lots of various pieces of technology. All it takes is one to have a problem at some driver layer or something like that, and data doesn't flow. And with all that, we still don't have a way to combine our server performance metrics with which queries we're running at the time. That's ultimately what we need to do, is figure out which server resource is constrained at any given time. And then our SQL Server would run so well if it weren't for all those darn queries. Kind of a silly way of just saying that, all of those resource consumption, all that comes from the queries that are running. So we need a way to marry and figure out which queries we're running at the time so that we can ease the pain back. So that means we're going to have some kind of a profiler, maybe a server-side trace running all the time, but only tracing against some of the events, not all the events, or X events or something like that. We need some way that there's the queries are being recorded in a fairly lightweight way, saved off into tables, or some way that we would be able to then correlate and marry that together so that now we can start getting to the bottom of what some of these problems are. So there's a couple different pieces, right? There's all this technology around booby trapping the SQL Server so that we have the tripwires in place to know what is going on the server. But then when we get values back, for example, 15 millisecond I/O latency, we need to interpret that. We need to figure out, is that good? Is that bad? Am I ahead of the game? Am I behind? Is that average? So we need that, and we also need a way to report all this. So if we have all these recordings happening, some in files, some in SQL tables, some in jobs, some in PowerShell, some here, some there, we need to kind of pull that all together so we can easily see it. There's no way that our customers can say, hey, things are extra slow right now, go fix it, and we're like, can you tell me where or how, or hang on, let me correlate 17 different things all at the same time. It's going to take a little while to do that. So now we're talking a whole nother aspect to the monitoring solution, which is Power BI or SQL Server reporting services, or some way to get that data digested, to make a chart out of it or something like that, or some line graph so that we can see, oh yeah, I see the spike, here's the metric, let's correlate this to something else. So all of this means that if data doesn't flow, and it takes a long time for the DBA to figure out what's going on with the technology, if there's any problem in the whole stack, we've got to figure out now which part of our stack is broken, which script, which ODBC piece, which part is not flowing in, and constantly keeping that up to date. And then good luck next time we upgrade our SQL Server from 2014 to 2016, or Windows Server this to Windows Server that. It's going to be more things that can possibly break or not work with all of our various technologies. So really quite a pain to deal with when we're doing that the manual way.
I agree. I mean, the manual approach, you're just more likely to miss something important. Right? There's a lot of things that can go wrong. It's hard to check for them all, if you're doing something manual. One of the best attributes to, I think, this product here is if I go to the alerts area and go to configure alerts, I just want to show the group here, the amount of alerts that we give to you out of the box. Things that are, I think, as important to all DBAs in terms of just making sure that there's nothing going on that's going to adversely affect the environment. You want to look for things such as, your low disk alerts, your overdue backup alerts, your AG failover alerts. Right? These are all things telling you about a problem which might be happening in the future, but gives you time for you to take corrective action before it becomes a real problem. I doubt, I'll go out on a limb and say that your manual monitoring right now that's going on is not going to be able to catch, all of these, as well as many, many more. Let me go back over here into the overviews, just to kind of give you a good idea in terms of the information that we're presenting to you from SQL Monitor's perspective here. So I'm going to drill into an instance here, and right off the bat, you see a graph that's representative of all of those different baselines that we're looking for in terms of your CPU, your memory, your I/O, and your weights. And then underneath, you see a couple of interactive graphs here in terms of those metrics. And as I scroll down, just to kind of compound on what Jim is talking about here, this tool will provide you the top 10 queries and the top 10 weights indicative of a time that you are trying to investigate. So up here on this graph, I can take this box and I can slide this and zero in on any particular point in time that might be of interest. And if I release my mouse on a time that's not real time, those queries and those weights that were collected during that time are going to also be presented to me as well. So again, right there, I can go ahead and select a query. I can also look at a query plan, okay? And this is, again, something in terms of having a tool for you at your fingertips. This is something of value that goes beyond recognition here. And one of the things I like about this tool, when you look at the query plan, you'll also see here, it will give you some ideas in terms of how to fine tune this query as well. So not so much from a monitoring standpoint, but now we're also going to take it one step further from a performance tuning standpoint as well, which I think is also an attribute that you should be looking for if you're going to introduce a monitoring tool into your world.
Well, once again, that's pretty cool. Okay, good. Well, thanks, Chris. Appreciate that. Okay, great. So then, so we're looking at some of the issues of doing this the manual way and contrasting that with some tools that work out of the box and kind of solve all of the problems. That's really good. Okay, great. So the next area we wanted to look at was that problems can take longer to resolve. Yeah, I'm talking about customer problems would take longer to resolve. Before we were talking about all the problems dealing with all of our band-aided together pieces of technology for our own monitoring. But now we're talking about customers and the response time that we have as DBAs. So because it's difficult to identify exactly what caused the problem when we do things the manual way, and when the problem exactly happened, It's therefore much more difficult for us to hone in on and resolve the issues, especially before the customers notice. We don't want to use the other monitoring tool, that is our customers complaining at us, telling us when the system is too slow. So our issue is slow detection time. When we're doing that daily checklist first thing in the morning, we only get a snapshot right in the middle of right in the morning. We have no idea what's happening in the middle of the day or throughout the day. So that means we won't notice any spikes or any valleys at all throughout the day unless we're recording information regularly. And on top of that, if we look at just the daily average first thing in the morning, what's the average of this or what's the average of that? Excuse me. Then if we see the overall average for the day, or worse yet, the overall average that we're pulling from cache from the DMVs or since SQL Server last restarted, then we might see an average I/O latency, for example, of 10 milliseconds. That looks fine. What we won't notice is throughout the day, there were periods that were super fast and only 2 millisecond latency in I/O. That's great. But then there's also different parts of the day where it was horrific and 100 milliseconds or more of latency during the day. And therefore, our customers can complain that, hey, yesterday at 3 o'clock, things were unbelievably slow. And if we take a snapshot point in time without having a recording of everything that's been going on this whole time, we would just look and say, well, what are you talking about? Everything looks normal and average and fine. And that's not a really good answer for us to tell our customer. Really, it would be better if we find these things ahead of time so that our customers don't even know. We can head it off at the pass. So because of that, we need some kind of a 5-minute sample, or more frequently or less frequently, maybe depending on different metrics. Some metrics we want to snap at 5 minutes, and other metrics we want to snap once an hour or every 15 minutes or something along those lines. Therefore, we're not putting too much load on the server, but at the same time, we're getting enough granularity so where all these averages and data points mean something, so we can see that, oh yeah, it wasn't at 3 o'clock, it was at 2:58, and here's the query that was running at the time that was causing the problem. This will allow us to detect those anomalies. So we can define a perfmon capture set, and again, we can put that into a file, but good luck correlating that to queries midday. It can be done. It's just kind of a pain in the butt. So when we also see an anomaly in CPU or I/O latency or some other of the thousands of perfmon collected metrics, can we figure out which query was running at the time? So we'll need a constant server-side trace. We'll need to snap those queries maybe out of cache every 5 minutes, throw those into a table. But don't forget, that's going to be more purging code that needs to take place to scrub that stuff off. So it adds more to your project. So either way will work fine. It's just more complicated, and we have more risk of there being errors if something doesn't work right. So the problem with that is that starts making us more of a reactive DBA. Instead of getting ahead of the curve and really making some meaningful improvements, we're constantly catching up and keeping up and being chased around by our customers or our users as to why things aren't working well. And then we're trying to fix all of our multi-technology solution. So we don't want that. Instead, we want to be proactive. So we don't want our day to be spent trying to figure out if anything is even wrong or not to begin with, and also how we can better monitor the server. The more time we spend on that, the less time we're actually doing DBA work. Pardon me, my fingers are getting ahead of myself. So that allows us to spend more time. If we had these issues solved, we would be able to spend more time, say, on our dev tier or test tier, working with the developers saying, hey, you know what, we're noticing under load that this new code base that's coming out has some performance issues, whether we have to make adjustments to the T-SQL or change some indexes on the server side or server settings. Those are all things we can find before the workload ends up in production. That's where we should be spending our time rather than trying to just keep the wheels on the bus on our production box. We can find that whether we're doing execution plan work and adjusting indexes, we might improve queries by 400% or faster or whatever. In fact, let me tell you a brief story about one of our customers. We have one customer that's in the cloud. They're in AWS. They have about 730 servers total, but of those, about 50 are SQL servers. And with those 50 SQL servers, these are very expensive SQL servers. They're using like 4XL or larger servers with $1,000 a month drives. So the instance is a whole lot of money per month. And then the drives, they have like 7 or 8 drives per instance. Each of them are $1,000. The EBS drives at 20,000 K dedicated IOPS. So they're pretty expensive. So the problem is, if they have periods of time during the day where the workload is extra stringent, then they don't want to have the risk of people complaining. So they just have an extra large size everything. You know, scale up. It's much easier, especially in AWS. No problem. 3XL doesn't work. Make it 4XL. It's going to cost you an arm and a leg at the end of the month, but that's finance's problem. So the issue is they end up spending a tremendous amount of money, over $1 million a month on AWS in order to keep all of their servers going. So instead, by having somebody that is able to get ahead of the curve and not just trying to keep production barely working, instead, if we're able to look at when are the peaks throughout the day and what could we do to tune, adjust, monitor, use execution plans, surf through there and make index adjustments, T-SQL adjustments, work with the developers on their load test here, then we're able to ease that back. So instead of having to have those very expensive drives for all 7 of their volumes, maybe they can ease it back so that it's only for 1 or 2 of their volumes. Does TempDB need it or not? Who knows? Not unless we monitor and figure that out. Does the instance need to be a 4XL? Maybe we can tune that back so it's only a 3XL, which doesn't sound like a big change, but believe me, when you see the bill, it's a big change. So those are the things that, in my opinion, a DBA would really spend his best time doing rather than just trying to do the fundamentals of the monitoring. Okay.
Yeah, I think all good points. I mean, slow detection time, being reactive, you know, these are real attributes. You know, when there's a problem, time is money. All right, you've heard it a million times. You'll start having people, you know, start yelling at you. You might have some business units telling you, equating that, you know, downtime starts to very quickly start to add up in terms of lost revenue. You need to have all this information at your fingertips. SQL Monitor already has the information that you need. Okay, so as I come into this this monitoring environment here, let me get rid of the report here and start showing you, you know, just a little bit of attributes, especially in terms of when we start talking about going back in time. So as we saw before, we have all of those top 10 queries, top 10 weights, but up above here in this graph, you can see, you know, you have the ability to go back in time. Which I think is a fantastic attribute because obviously, you know, we live in and work in the real world. You might not have a circumstance, you know, where you're prepared for instantaneously. And we all have those issues, you know, where users come up to us after the fact. All right. You know, the other angle about this whole process is that your job is sometimes about, you know, how quickly you can work out a user's problem when it isn't really a problem at all. All right, so you don't really spend a lot of valuable time trying to research an issue that might not be there. So if I kind of look at an instance here, for example, you know, I'm kind of filtering out a lot of different alerts here and just selecting a couple of different obvious ones. Let's just take like processor utilization, for example. I can look at all of my processor utilization alerts that have spiked. I can start to dive in. You know, end users come to me. Of course, SQL Server is the root cause of everybody's pain, and now it's up to me to rule out first and foremost the SQL Server and start not only ruling it out, but also giving some people some concrete evidence of where that actual issue is. So I can look at my CPU processor, get a real dominant view of that particular spike. I see it. Okay, was that the cause of my user's issue? Let me continue my investigation. I can start doing some comparative baselining now. Let me look at what this instance was doing, you know, this particular time 24 hours ago. And you'll notice here, you see a dominant blue spike, and then you see a very light blue heartbeat in the rear. So at least from my perspective, 24 hours previous, I had a similar attribute in terms of my processor. Let me extend that baseline out even further now. Let me start looking at it over a period of days. I can even switch this view over to a regional view, give me a little bit more of a visual representation of the behavior. So look at where I've gotten already just in 3 mouse clicks in terms of my investigation. I challenge anybody on this webinar to do this from a manual standpoint and get to where I am at right now with respect to my investigation. So right now, at least from the all intents and purposes, I can pretty much comfortably say from where I'm sitting that, yes, I see CPU spiking at this particular time that affected my end user. I've looked over a historical trend here in terms of this metric. I see the actual same spiking occurring over the same period. So obviously now it's just a perspective of, let's go ahead and start finding out what's been running on my host, what's been running on my SQL Server, get root cause, and put this baby to bed.
Wow, that is really cool. Thanks, Chris. Okay, so what am I doing? Here we are. Okay, excellent. So let's go on to the next part here, which is when we do things the manual way, then we start worrying about data privacy. We hear all these things in the news about hacks and problems. So because of that, there's all kinds of compliance restrictions that have been there, and they're getting more and more stringent. So an auditing trail is more and more important. So compliance is becoming ever increasing issue. Tracking and managing our data is more important than ever before. So we need to have a good audit trail in order to prove that we're in compliance. But how do we do that? That's not going to be cheap. It's not going to be free. It's not going to be cheap. If we choose to build our own solution, it'll take a ton of time and a lot of thought in order to create audit trails. And once again, we're back to having more and more and more data in order to audit. And then we have to purge that data and manage that data as well. So it creates several problems. And unfortunately, there's no way we can just tick a checkbox and poof, now there's better auditing involved. It's quite difficult to audit our servers to support the compliance that we're under. Compliance requires audit trails, whether we're bound by HIPAA or SOX or SOC2 or ISO or any other compliance that our industry or country demands upon us, that we really need to have supporting data in order to prove that our server is in compliance. So audit trails allow us to reconstruct the sequence of events and analyze problems like unexpected system behavior and debug some of those issues from that perspective. So a good audit trail is important to protect our data and to make sure we keep the private aspects of our data private. However, if we monitor manually, build our own complicated monitoring solution, we'll have to spend all this time building our audit and compliance parts also. So our project keeps getting bigger and there keeps becoming more and more pieces of technology stitched together. Okay.
Okay. I mean, from an auditing and compliance standpoint, I think there are other tools within the Redgate portfolio that might be a little bit more specific. From a SQL Monitor standpoint, I want to kind of bring you to the attention of some customized metrics that we have embedded in our tool here. And you can see a repository that we have compiled over time, and in particular from an auditing standpoint. So here you can see various other customized alerts that you can bring into SQL Monitor that help you go about just making sure that at least from the monitoring perspective that we're not seeing anything abnormal. I'm not finding any untrusted check constraints, for instance, any failed SQL Server logins, those types of alerts that just really allow for you to tie into your overall auditing and compliance processes there. As we move forward within the year, I think that this will become even more of a feature set within SQL Monitor as well.
Okay, cool. So then, Chris, that part there, those are community-driven pieces, right? And therefore, they'll constantly be on the change. More people will be adding to them as they go. Is that right?
That's right. I mean, this is something that I think is a fantastic attribute to Redgate. So what you're looking at is really just a conglomerate of additional asks from our customer base after they've purchased SQL Monitor. They might have some certain attributes that they're looking for to bring into their monitoring solution. They are not a part of the out-of-box alert scheme. So they came back to their account teams with some asks in terms of alerting, and the SQL Monitor team was very generous to compile that T-SQL commandlet for the customers, provide that back over to them so they can go ahead and bring that into their copy of SQL Monitor. And over the years, those asks have, of course, grown to the point now where you see a very robust repository there in terms of all of the different commandlets that are available to you as well once you bring in the product.
That is cool. Yeah, I especially like how it's not yet a different technology, some scripts that require a table, that requires a job, that, all these little bits and pieces. Instead, it pulls right into the product. I like it. I like it. I like it. Okay, cool. Okay, so the next part we wanted to talk about was restricting the DevOps process. So lots of teams now are adopting DevOps practices with automated build, test, and deploy of their changes to their database. This helps reduce the number of unexpected errors in the production environment. So in the olden days, back when I was a wee lad, right, we would have to manually deploy to some other box and then dream up some kind of a workload. And then if we had lots of different servers in production, it was just hard to wrangle and manage and deal with. But now with much more sophisticated technologies with CI, CD, that really helps us to use tools like Octopus Deploy or Jenkins or VSTS, Visual Studio Team Services. These are all great tools. They're external tools, totally different tools, which gives us, yet, you guessed it, more technologies to manage and work with. So when we have our own changes, as we monitor our SQL servers, that's no doubt going to lead to changes that need to end up in production. Whether these are index adjustments, which should be scripted, whether these are SQL settings changes, max stop, thresholds, max server memory, just all kinds of things from that perspective, or T-SQL coding changes, stored procedures, triggers, user-defined functions? No, you should just removing the user-defined functions, really. I'm just kidding. They have their place. But at any rate, there's lots of changes, and those changes need to be scripted rather than just performed right in production. And the best, most effective way of doing that is to run those on a lower tier server that's not production, and then apply a workload to it in order to make sure that our system scales or even improves, and especially doesn't degrade as we go. So with that, how do we manage all that? If we have our own monitoring, how do we, developers have sophisticated one-click deploy all of their new juicy code bits, and one-click deploys and off it goes, and it's great. And then in the world of DBAs, we're still stuck back in the days where we have all these scripts and we number them 01, add the column, 02, add the index, 03, change the stored proc to whatever, and we have to run them in just the right order and don't get them out of order, otherwise it's, things break and now we have more stuff to debug. You probably know what I'm talking about. So, but with DevOps now, we can start improving that, and as we have our code changes, we really need to find a way to kind of fork in along with the developers so we can have continuous integration and continuous deployment as well. And what's more, how do we even detect changes in production? Of course, there should never be changes in production. That's disallowed, but sometimes it happens. Are we going to have DDL triggers? I suppose we can, but if only there were better ways to detect changes in production, and also to make sure that our changes, our proposed changes to production, are controlled through a certain DevOps process. Hang on. I'm still learning how to use PowerPoint. Just kidding.
No worries. So, I mean, DevOps. I think this is an area that Redgate is at the forefront with respect to everything that we're doing, at least from the database lifecycle standpoint. But now, how do we, bring that into SQL Monitor? First off, let me bring you back into an instance here. And what you'll notice on this toolbar, along with these little blurbs here that you see that are indicative of an alert being triggered, I also want to bring to your attention this little icon here. So we are tightly integrating our monitoring tool with all of those automated releases that come in. So now I can track those as they get released into production from a monitoring standpoint. This just gives me even more data at my fingertips. I can understand now what that pre-release behavior was on my instance versus post-release. Now, if I start to see and track those changes as they come into production, and I notice, of course, things going haywire in terms of CPU spiking or disk I/O, it's pretty safe to say that we can again zero that down to this particular release and act accordingly. And lastly, I think it's an important step on the journey to DevOps is really about bringing development and operations closer together. As part of that, that means bringing developers closer to the production environments that their code is deployed to. And that means also including having access to data about how those environments are running. It's about enabling more people to have access to that data. So one of the beautiful things about SQL Monitor is that you are able to, provide those authentication views through Active Directory. Okay, so in this case here, I can give those granular permissions, based on AD. It allows me to assign only specific servers to individual developers or teams, the views that they can see only in the environments that they're responsible for. Using a manual approach for this is difficult to do without saying. Even if you grant developers access to the servers, which I'm sure many of you won't be keen on doing, or to give data that you manually collect, knowing what to do or how to analyze, interpret any of that data that you're manually collecting is just a big ask for any development team. And I do believe, and I'm humbly believe that SQL Monitor makes all of that process that much more easier.
Like it. Okay, great. Okay, cool. All right, so in summary, we have the manual monitoring, which is time-consuming, checklists, baselines versus actuals, various technologies band-aided together to make an incomplete solution that now we have a new project that we have to manage and wrangle. Really what we want to do is not increase our failures, but reduce the risk of failures. That is human failures, DBA fatigue, adding our technical debt, which is expensive to pay off and very frustrating to deal with. Also, problems tend to take longer to resolve when we do things the manual way. So that leads to slow detection time and makes us more of a reactive DBA. It's not a good reputation to have, I don't think. And we also risk data privacy, having poor audit trails, and it's very important as a DBA to protect our data and to show that our most important honeypot is safe and within compliance. Also, with the manual way, we restrict our DevOps processes. We don't want to do that. We want to detect changes into production that happen regularly, and we want to manage that process, jumping on board with the CI/CD, continuous integration, and deployment tools that can help. And SQL Monitor can really help with these things by, instead of us building our own solution, which is never going to be done and always lagging behind the technology and the business needs, and also having fragile technologies all stitched together, instead we can just write a check to somebody like Redgate or whoever in order to get a monitoring tool in order to pretty much solve all of these problems and let them deal with building the project, and we can get back to just being DBAs. And also in summary, SQL Watchman, we can help you fix the problems found that SQL Monitor was able to find. So with that, we'll go ahead and open it up to questions and answers. And let me see if we can figure out where to find those questions and answers. Maybe Kate might be able to help too. Let me see if I can find some in here. Okay, great. Okay, let me see. So the first question we have is from John, and he was asking how does SQL Monitor deal with more than one or two servers? Do you want to take that? Or do you want me to take that?
So not really. Maybe we can now elaborate a little bit more on the question. When you say, how does SQL Monitor deal with more than a few servers? Very easily. So, I mean, this solution is an agentless solution. So you can very comfortably bring, up to about 200 or so instances under one version of SQL Monitor. And as you saw initially, you're able to collapse that view as your estate grows. So you have a very easy, holistic viewpoint of one up to, X amount of servers within SQL Monitor. That was, and if that's not, touching on your question, please reach out to me and we can handle that offline. I see another question here. Stephanie's asking about licensing. How is SQL Monitor licensed? This is a product that is licensed per operating system. And then when it gets into licensing, and you will have to just bear with me, I'm a pre-sales engineer. I do not like to trample on any of my account teams, but I will be more than happy if you would like, reach out to me offline through email, and I will be more than happy to connect you to the prospective account teams, and we can take care of your licensing questions.
Okay, cool. Let me see. Jerry says, great webinar. Thanks, guys. Hey, thanks, Jerry. Glad you got value in that. Okay, cool. And yeah, also with the large estates, I did a webinar with Redgate. What was that, about a month ago, about large estates of SQL servers, and we were talking about a couple installs out there that are several hundred SQL servers. Unfortunately, in the demos that Chris is showing us today, where it showed one or two or three different SQL servers, is a great way to organize all of those and be able to display them on the dashboard. So pretty cool stuff. Okay, cool. Well, that's all the questions that we're seeing for right now. If you have any further last-minute thoughts that weren't covered, feel free to slap those in the window here real quick. In the meantime, we'll put up our contact information. Feel free to contact either SQL Watchman or Redgate. That's how you'll get in contact with us. And also, my Dropbox is full, so everyone should know that. Okay, excellent. So, and we'll give it about 30 more seconds to see if there's any further questions that come in. And other than that, we want to thank you for attending today. We had a great time, and I think this was good content, and hopefully you found some real value out of this. All right, thanks everybody.